So hi everybody, my name is David Bianco. I work for Mandiant, but I've only been there for about 4 months. So before Mandiant, I was with a Fortune 5 company that I will not name because I'm no longer speaking for them right now. But I want to tell you that even though I have the Mandiant branding because I'm a corporate dork, honestly the real reason is I can't make anything pretty, so don't expect too much out of my graphics. But even though this says Mandiant at the top, this is actually based on work that I did before I came from Mandiant. So this is 100% what I did when I was working on an enterprise detection and response model for a Fortune 5 company. So of course, if you go back in the history of time, this is pretty much where everyone started. Snort or something like it, some IDS system, where you just get an alert, you get a little bit of data, maybe you get a packet that triggered the alert, but then your analyst has to do a lot of work to kind of validate that alert and do some research, and kind of really untenable, especially IDS is especially untenable today, but even then it was pretty untenable, we just didn't realize it. And then, like the end of 2004 or so, Richard's book came out, the Dow Network Security Monitoring. That's actually how I made the transition from IDS into NSM. And the big idea from NSM that makes it so different is it is intrusion detection, but it's also plus this other data. So other supporting network data, network sessions, full content PCAP. We've seen a few other things today that fall into the NSM camp, such as asset detection and things like that you can gather from the network traffic. And just a quick side, at the time that I started implementing this using Squeal, we went from having like one snort sensor at the perimeter of our network and an analyst spending 6 hours a day trying to find out where all the information that they needed to validate their alert and do their research, to having 4 sensors at the perimeter and three inside, one at the perimeter, 3 inside, and only spending about 2 hours a day. So we actually quadrupled or more the number of alerts we were processing, and we cut the time by 1/3 to process it. And it's all down to having the network sessions and especially the full content packet capture available in a nice tool like Squeal to bring it all together. And this is pretty much where we started at my Fortune 5 employer. We were hired on to start this from scratch for the whole company in almost 200 countries around the world, all of our business lines. It's a giant company. It's probably one of the largest organizations in the planet, to be honest. And we started off with, I think we had like 4 of these sensors, Squeal sensors running at first. And by the time I left 4 months ago, we were nearly up to 600. I don't want to brag.
Go ahead.
And we had like literally petabytes of PCAP data sitting around on disk waiting for our analysts to pull it on a regular basis. And we were sending something like 2 terabytes of data of network sessions and HTTP records into our database. So we pretty much by that point had exhausted the scale of NSM. So we were getting great success from it, but we were really looking at, okay, what is next? What can we do to get better at what we're doing? Because we feel like we've pretty much reached the limit of NSM. Even if we added another 600 sensors, it'll give us more visibility, but it's not going to substantially improve our ability to detect or respond. And so we were looking for something a little different. So what I spent about the last year or so at this company working with, along with a friend of mine, Brian Stillians, who I would be remiss if I did not mention his name because he has a lot to do with what I'm talking about as well. We came up with this, what we call enterprise security monitoring. So you have IDS and you add some other network-based data and you get network security monitoring. Well, in our model, you have network security monitoring and you add some other enterprise data into it and you get ESM, enterprise security monitoring. And you get the same kind of jump from one level to the other. When we jumped from IDS to NSM, it was like, ooh, this is awesome. Well, now we've got in a fully functioning NSM shop who needs to make the next jump. And that's what I'm going to talk to you about. The first half of this presentation, I'm going to be talking about ESM and a kind of high-level blueprint of how you would do this. All the presentations leading up to today, this was totally coincidental, I guess, but I'm the last of the presentations that have to do with Security Onion gathering NSM data and ELSA gathering all this other kind of enterprise data. So you can think of it now as I'm going to tell you how to give you a blueprint for doing this in your organization. I'm also the first person, by the way, who doesn't have code to present. I don't write code for this. This is not a programming talk. And in a lot of cases, it's not really a technical talk. Sorry. This is just a little diagram to show you the representation that I already talked about. Snort plus other stuff is NSM plus other stuff when you get up to ESM. So the benefits of enterprise security monitoring. There's a number of benefits of why you would want to approach this that I'm going to tell you. First, you get even increased visibility. I'll be honest, when somebody has 600 NSM sensors say he needs increased visibility, I'm talking about a really large increase of visibility here. We also get more value out of existing systems. You'll see why in a second, but the whole idea is to turn everything that you have that can generate logs of any sort into a detection platform. So you'll get more visibility because now you have all these host-based or application-based things that are not just network sensors. And everything that you've already deployed, even if you didn't consider it a security system in the first place, is now an intrusion detection mechanism. We're going to put all this in one place. We're going to aggregate it in something like ELSA or Splunk or something. So it's very hunter-friendly. We talked about hunting. Richard talked about it in the keynote. Doug talked about it earlier. Martin was basically showing you, and Brad and Chris were basically showing you how to do hunting. Having all this data and having it all in one system is very hunter-friendly for all those reasons that we've already seen today. I'm also going to talk about some better organization about the intel, because to me, just having this data is not very useful. So our approach is very intel-focused. It's intel-driven. And once you start thinking of intel-driven processes, then you can start thinking of, well, what intel do I have? How do I organize it? What questions do I need to ask about the intel that I have to make sure I have an effective program? And we're going to talk about that. But the real goals here, no matter what I said up to now, the real goals here are two. First, quicker, more accurate incident detection and response. So you'll be alerted to something happening more quickly, and you'll have more data to answer your questions more rapidly so that you'll be able to do something about it more effectively. And the last thing that I really enjoy is I see it as leveraging your detection and response infrastructure to cause pain to the adversary. You make it harder for them to do their work. You can't stop them. They have the will, they will do it. But you can make it as difficult for them as possible. And you can almost turn it into an offensive capability or counter-offensive capability. So I said, first of all, that we're intel-focused. I'm going to spend this in the next few slides talking about a few cycles that we have. I'm not an intel analyst. Some of you in the room might have some intel background, but I don't want to say that I'm an expert intel analyst. So I've written this as very high level, but this is a high level view of what a corporate intel team or a corporate intel function or even an outsourced intel function would do for your response team. They do some research into threats, they gather some raw data, they analyze it, break it down a little bit, and make some conclusions like the intel. And then they use those conclusions to further go back into their research. Well, I've concluded that this group is in China. Well, what part of China will they be? Well, some of the parts of China have different specialties. So let's find out what those specialties are. Do some research. Analyze that. Oh, I've got a table of the specialties now. Oh, now I can make a new conclusion that this must be from, I don't know, Guangdong province or something. So the output of the intel functions go usually into your detection process. The detection process, again, high level, is you observe things that are going on in your enterprise. You compare them to the intel that you have. And the intel could be as simple as, I've just got some snort signatures that I know that this kind of attack looks like this and is going on in the internet today. Or it could be more detailed. It could be something like the APT2 report that we published earlier this year. I'll try to make that the last time I mentioned Mandy today. And then when you find those things, you do some alerting, and somebody has to validate that alert to say, hey, this is a false positive, I don't really have to care about it, or this is an actual real alert somebody had better do some response to. In which case, you get into the response cycle, which at a very high level is you contain the problem to keep it from getting any worse. You've already got a validated alert, so the first thing you do is keep it from getting worse to buy yourself some time, okay? You investigate it, try to figure out what they did, what they got access to, what they tried to do, maybe they were unsuccessful with. Make sure you've got the whole scope of the incident. And then once you have the whole scope of the incident, you can start remediating it and putting things back in their proper order, ejecting attackers, re-imaging systems, putting them back on in production use. So these three cycles are not really separate. They're, in fact, parts of an overall cycle, which I could have drawn as a circle, but I didn't. And you see it starts over here with the intel cycle. The output of the intel cycle would be indicators. I'll talk a little bit more about indicators in a bit. The indicators come into the detection cycle. The output of the detection cycle is an alert, a validated alert, and then the incident response folks take over there. And their whole goal is to get down to the remediate stage from as quickly as from alert to remediate as possible. Actually, as quickly from observe, where the event actually happened, to make a quick alert and then remediate. And you'll see that each one of these stages has a database of some sort. It might not be actually like a MySQL or a Mongo database. It could be a collaboration tool like wikis or something, especially on the containment, or excuse me, on the response side. You see a lot of tickets and wikis and knowledge bases, collaboration tools, rather than just straight up MySQL databases. But it's a place that they store all their information so they can look at it over time, see what they did about something a year ago, last time they saw it. And then these are all also related by feedback loops. So I come from intel to detect to respond, but I also get back feedback. So I can say, hey, your indicators were not too good, and send the feedback to the intel team and they can revise their indicator. Or they can say, the responders can say, dude, your alerts, you're just not alerting on the things that we need to know about, or you're still giving us too many false positives even though you said it was validated. Or even, your alerts are great, but they're based on faulty intel that the detection function didn't know was faulty because they don't have the same view of the network. So those are the processes involved, but they all need data. So from the ESM model, we start with the intel coming in. And the intel can go into two places. First, it goes into this thing we call the Enterprise Security Monitor. The Enterprise Security Monitor would be like Splunk or ELSO, or you could do it with a SIM, although I don't really think of a SIM as the ideal for this. The intel goes in there. It also goes through this detection processing to create actionable signatures for your real like IDS platforms and Security Onion and Bro and Snort and Suricata and whatever. And they feed into there. And these all, again, feed into the Enterprise Security Monitor. But you also have any other data that you have in your enterprise. So firewalls, routers, switches, network infrastructure, operating system or application logs, proxy logs, web logs, antivirus, HIPs, HIDs, VPN logs. Who's got a log? Seriously, like throw out some logs that are in your environment. DHCP logs. DNS tables, DNS, yeah, all these things. If you're logging it and you're not capturing that information, why the heck are you logging it? And if you are capturing that information, capture it all in one place. So your analysts or your IT ops people or anybody really in your company know where to find that information when they need it. And then your analysts here can talk to the enterprise security monitor. And they get their alerts from the EDSM, and they'll, when they want to validate them or when they want to do their responses, they can send queries back and get results. Everything goes through one place. There's nothing wrong with Security Onion, right? But the demo that you were showing us this morning was go to this tool, pivot to this tool, pivot to this tool, which was great actually because that is like the foundation. You have to be able to do all those functions, right? But the slightly better way is to build it all into here so that you don't have to. And actually Security Onion really does work that way. I know that in a lot of those things you were just showing out how you could use the different tools, right? So Security Onion is a possible implementation of the enterprise security monitor. It doesn't necessarily, by default, include a lot of this enterprise data, but it has the same architecture. So let me ask you a question. I said indicators a few times already. What is an indicator? Anybody want to disagree with what I've written on here? Piece of information points to a conclusion. Okay. Now let me ask you another question. Given this definition of an indicator, do you feel confident that you have indicators that can go into your detection mechanisms safely? It's a trick question, actually. So when you say indicator, this is this is the definition of an indicator. But in a lot of times when we're talking about indicators for Intel-driven detection and response, we actually have a few different kinds of indicators. First of all, I want to mention, and this is something I see a lot, an indicator is not the same as a signature. So I've seen a lot of people say, like, I've got a snort rule, I'm going to capture that as my indicator. That's not your indicator. You take the indicator, which is the raw output from Intel. The output from Intel, you don't want your Intel team creating signatures for you. I don't want my Intel team writing snort rules. God no. But I want them to give me good quality indicators, and then I will take them as part of this box here, the detection processing. That's where you turn indicators into signatures. And there could be a number of different data types for indicators. Indicators could consist of almost anything: IP addresses, transaction user elements like user agents or mail server types or something like that. File names or paths or mutexes on the system, or even a username that you know or suspect is compromised, an email address, a hash, all kinds of stuff. This is not a comprehensive list. And I say indicators have three characteristics. First, they're extractable. Can I find this indicator in my data? If I have an indicator that either I have no data to back up, I can't even begin to look for it, or if it's an indicator that I can't really find in my data because, I don't know, the indicator is a plain text string, but it would be found over an encrypted session, can't find it, can't extract it, not a good indicator. Leaving the middle one aside for a minute, the next one is actionable. If I do find this indicator in my data, is it something I can do about that? So we get these things from, like, don't want to pick on somebody, but I'll say DoD, right? And they'll be like, hey, these are the list of indicators for this attack group, this threat vector. And they'll be like smtp.aol.com, something, which is context dependent. So at a military site, that might be actionable, because they might not get a lot of AOL traffic. But in the corporate world, you get tons. In the educational world, you get tons. It's not actionable, probably not a good indicator for you. And then the middle one here, purposeful. To what use will I put this indicator? To me, this is the biggest thing that people don't understand about indicators used in Intel-driven detection and response. There's actually at least four different types of indicators. I actually had somebody tell me the other day that they had thought that there might be a fifth kind. An attribution indicator. This is what your Intel team probably uses. Who or what is responsible for this activity? Detection indicator. If this event happens, I want to know about it. This is something you can actually look for in your data. A profiling indicator, like this is the threat actor, who are the people in my organization, or what business units are they likely to go after? And then a prediction indicator, given whatever just happened, can I make some prediction about what I should be looking for in the next number of weeks or days or something? So a good example of an attribution indicator is smtp.aol.com, right? So we have, say you have 24 different threat actors that you're tracking. A subset of those, 5 of them, have the habit of using AOL messages. So it's an attribution indicator because it takes out 19 of the possibles and gives you, say, this is probably one of these 5. You combine those with other attribution indicators, and you might narrow it down to 1 or 2 actors. They're low fidelity. Maybe. Sometimes they're really high, but they can be low fidelity because it doesn't matter, because it's not that you do attribution based on any one indicator. It's a preponderance of the evidence, so it doesn't matter if they're low fidelity. It's not going to cause the Intel team any problems. It causes you problems if they try to send them to you to your detection systems, though. The detection indicators are more high fidelity. They can't probably use smtp.aol.com as a detection indicator, although it may be a very good attribution indicator. A profiling indicator would be something like, well, this group is interested in nuclear energy, or this group is interested in things that are going on in a certain city. So I would say that my people that live and work in Augusta are at higher risk of being phished by this adversary. A prediction indicator is really interesting. So I had one of these. I don't see these very often, but I do occasionally see these. We had one where we just published a press release about a new research center we're opening in this business area and this location. And our Intel team said, well, based on that, I can tell you that this particular threat actor is going to start web-based recon against this web server sometime in the next 30 days. Because they had noticed, they had derived some intel that said, prediction, actually, and profiling, they said, this actor is interested in this business segment. And when we've done this in the past, we noticed that within 30 days, that actor will say, I'll target the web server that originally published the press release and start doing web-based recon to identify the names of all people in that business area or our employees in that local area where the business is going to be, and they're going to get phished.
So what's the actual prediction indicator, though?
The prediction would be that because we just published a press release on this web server, we're going to see web-based recon to do that kind of enumeration within the next 30 days, and probably about 2 weeks after that, we're going to start seeing spear phishing to the people in that business unit or in that physical location. And they came to us and they said, you know, we need to be able to be on extra high alert for detecting these things. And we
So
were
it's like a narrative that is a warning.
Yeah,
Okay.
yeah. So, show of hands, who in here is familiar with the cyber kill chain? Okay, pretty good number. This is actually created by Lockheed Martin, so it's Eric Hutchins, Mike Cropper, and I forgot the first name. Rohan, yeah, sorry, Rohan. And it's a model that shows a typical attack progression for mostly a targeted attack, but it doesn't have to be. It can be adapted pretty easily to some of the other things. And it starts off with recon to do some research about the target, weaponization to create some kind of exploit package, which is then delivered to the target, and which is then executed in the exploitation phase. They install some package to create a command and control channel, which allows them to do whatever it was they wanted to do, rummage through your network, find your files, exfiltrate it, shut down your reactors, spin things too fast so you can't manufacture weapons very quickly. Anyway. So the kill chain model is not the only one you could use for this. Like Mandiant has its own. I lied. I forgot I had the Mandiant installed in here. Mandiant has its own, but the kill chain is probably the one most people are familiar with. And I've taken the kill chain model, and we use that a lot, but I've also added another model to it, which I call the pyramid of pain. And the pyramid of pain is a measure of if you have certain levels of indicators, detection indicators, that you can detect and respond to rapidly enough that you effectively demolish the adversary's ability to use that particular indicator against you, how much pain does it cause you? It causes them. So on the bottom side here, the wide part of the pyramid, we have lots of hash values. It's trivial to create a new hash value. A lot of times it's done accidentally because they added null byte to the end of it in transmission or something. It has a whole new hash value. So if you detect an adversary's files because of hash value, they're like, whatever, I'll send you a new one. Really easy for them to get around. IP addresses are a little bit harder, but not that much. They change a lot of times. The adversaries don't even care what IP address they're using because they're using an anonymous proxy or a Tor exit node or something. They don't even know what their IP address is, maybe. And so, yeah, fine. You blocked my IP. Come back tomorrow with a new one. Domain names may be a little bit more difficult because they actually have to go through the problem of registering a domain name, but not terribly bad because cybercrime people are just using stolen credit cards, or they have funds that they can buy hundreds or thousands of them at a time. If it's a nation-state actor, they might even have their own domain registrar, so screw it. A little bit higher level, though, then starts to get annoying. That's when you start being able to detect them based on network artifacts, like the protocol that they're using, the URL patterns, or things that they have for user agents or whatever. And on the host side, like that's where I know their typical file names or the mutexes or the registry keys that they use. They can change their code, but they probably have to recompile something or at least put in a new version with a new config file to get around that. If you start being able to see the same tool over and over again with different network artifacts, you may eventually get to the point where you can detect that tool no matter what they do. In which case, you've just destroyed their ability to use that particular tool. That's when it gets a little challenging because they got to either go out and get a new tool and train themselves up to use it as well as they could the old tool, or they might have to write a new tool, and you cause them a substantial amount of effort to get back in the game. And the highest level here is, what is it, salts and fats and sweets? The tactics, techniques, and procedures. That's their standard operating procedures for hacking. In other words, that's their education. That's how they know how to operate. If you can find a group that is operating against you because you know how they work, regardless of what tools or artifacts or domains or IPs or whatever, that's really difficult for them because at that point, what are their options? They have to stop doing everything they've been trained to do up to that point, train to be an entirely new kind of hacker, and then come back at you, which, by the way, is pretty much the same thing as I'm disbanding this hacking group, creating a new hacking group with totally different training. That's extremely difficult, and I don't really know of anyone who could actually do that. I mean, I guess with some of these adversaries, they could if they were determined enough, but if you can push them off and sit them on the top pointy part of that pyramid, they're not in a comfortable place, and they're most likely going to leave you alone. So this is what happens when you combine these two models. I'm going to discuss this in the next several slides. I don't have a good name for this, but yeah, it's like So the idea here is, for intel-driven detection planning, we need to answer several questions for our program. First is, what scenarios do we need to be able to detect? What kinds of indicators at what levels of the kill chain do we have in our Intel DB already. The next is, for all those that we need to be able to detect, what are our options currently in our organization that are already deployed for detecting each of those? And then, we may have multiple options for the same scenario. What are the strengths and weaknesses of the different options? Why would I choose one over the other? And once we get all that going, then we can start to answer some really interesting questions like, what is our detection stance against a particular actor? Like, based on what we know about this threat, how would we feel we're doing against detecting what they have? And then, what is our overall plan, an integrated plan for detecting any activity that's in our Intel database across our entire organization using the full spectrum of information that we have? Just some easy questions, right? I'm just curious, anybody feel like they have good answers to at least, I don't know, one of these questions? Nobody? Okay. Honestly, I kind of expected that, but I was hoping that. So first of all, this is the kind of scenarios that we have to detect. First question. So what I did was I took a hypothetical Intel database, and I said, well, each one of these bullet items here is a data type. It's not the type of indicator like for profiling or prediction, or these are all detection indicators. But I took the data type of all of them that I had. In our database, we record what kill chain phase that indicator is associated with, and it might be more than one. So what I did was I took all the ones that are associated with recon and dumped the unique data types I had, not the actual indicators themselves, just the unique data types. And I did that same thing for all of them. So you can see here, like, I have a lot on installation. I know, snippets of binary code, Windows processes, McAfee and Sophos antivirus street names for things, some hashes and IP addresses and everything. And notice that these are ranked in pyramid order. So the things closest to the top of the pyramid are at the top of the list. The things on the bottom of the pyramid are at the bottom of the list. That's not to say that the top of each list is the top of the pyramid. It's just the closest that I have in my database. I, in fact, do have a few behaviors, which is the top of the pyramid. Right? But I have almost all of these have like IP addresses or something, and hashes, which are in the very bottom. And so now I've got this scenario, this catalog of scenarios I have to be detecting. So I can make a list of all the possible detection mechanisms, not only like IDSs, but any kind of log sources that are going into my enterprise security monitor. And I can say, okay, this is what these are good at. And I cross off anything it's not good at. So Snort is not really good at finding file names on the disk. Not really good at finding MD5s. Not really good at finding, what else? Behaviors. Iffy if it's networked, but even so, Snort is usually more byte stream oriented than behaviorally oriented. So I cross off everything that Snort is not good at. This doesn't really tell me that much by itself, but I've done the same thing for multiple different things. So here's host-based intrusion prevention, so like an antivirus kind of solution. McAfee has a HIPS product to go with their AD, but there's other ones too. And some of these are different. So where Snort was crossing off almost everything having to do with the host and leaving everything to do with the network, this is kind of the opposite. Like, it doesn't do very well with HTTP GETs or user agents or IP addresses or something, but it can find hashes, it can find file names, it can find registry keys, it can find snippets of code, because this is basically what an antivirus does, right? So it can find, in some senses, it can find behaviors when they're doing actions on objectives, but not necessarily behaviors on command and control, because that's kind of network. And you can do this on multiple ones. If you have like a host-based response prophylactics or something like that. And basically what you end up with is layers. And you stack these layers on top of each other. And anything that is, when they're stacked up, if you have any of these scenarios that is not crossed off in at least one of those, you make sure it's uncrossed here. So like, I have at least one thing that's good at URIs in the installation phase, so it's fine. this says I have nothing that's really good at street name Sophos in the installation phase, so it's still crossed off. So now you can start to do some scorecarding where you can say some basic high-level things like, based on the intel that I have available, my detection program is doing pretty good at detecting it in the recon phase. I have very few, if any, things crossed off there. It's kind of iffy in the delivery phase because I have some things that are crossed off. And this is not just pure numerics. I wouldn't care too much if it was crossed off only hashes because they're very low on the pyramid. But I kind of care that it's crossed off behaviors. Behaviors are the most valuable kinds of indicators. So I don't want to see them crossed off ever. And because those were crossed off, I gave it kind of the middle rating, like warning, we could be doing better here, but we're not terrible. And then I don't really have any on here that we're really terrible at yet. And you do these across all of the kill chain phases. So this is how well we're doing with the intel that we already have. Now, this is a little different view. It says, based on the indicators that we have, not whether we can detect them or not, but are we gathering the right information, the right kind of intel at each of these phases? What is I call it the pyramid effectiveness of our intel gathering at that phase? And so you can see, there's some places where we're doing really well. Delivery, exploitation, command control, and the actual objectives, we've got them covered. We're doing really well because we have things at the top. We have a lot of things here in the middle. That's where we want to focus, the middle and the top. We have some things at the bottom, that's good. We have a couple weak points with installation where we really don't get too high in the pyramid. The highest thing we have is binary code, which is kind of mid-pyramid level. And that's okay, it's not terrible, but we don't have anything in terms of, this is pretty much artifact level. Where'd I go? Yeah, this is the artifact level, so like the mid-level of the pyramid. We don't have anything about tools. At the tools level, we don't have anything at the behavior level. We could focus a little bit more and try to ask our intel team to do some additional research to find those out. And we're terrible at weaponization. We have very few types of indicators, and they're all file names and file paths or URIs, so they're kind of mid-level, but we just don't have that much different kinds of data. And that means we can't bring a lot of our different tools to bear, so that's kind of, we don't get a passing grade there. I would say the weaponization phase is the hardest one to detect because it usually is action that happens at the attacker's computer because they're creating the exploit package. We usually actually detect the weaponization as it's delivered to us, but it still gets its own phase. And now, this is another view that you can have of this data. This is the kind of the pyramid effectiveness and the what can I detect effectiveness against a specific adversary. Mandiant likes to, I lied again. We like to number all of our adversaries, so I've given an irrational number. And we're doing terrible at recon or weaponization. We don't even have anything for weaponization for this adversary. And we only have, I can't even read my own slide here, URIs and addresses. So not, kind of mid to low level at the delivery, at the recon phase. And we're doing mid-level effectiveness all the way up until we get actions on objectives. We're really good at knowing what they do when they get inside. Honestly, that means they probably got inside a lot. Okay, so we have some places that we could improve. Obviously, the more green you are across the board, the better. But you especially want to focus on things like to the left where you are red, because we could potentially find some recon that preceded an attack by 1 or 2 weeks or something to give us some early warning and kind of help compensate for the fact that we're only marginal or okay at the other phases. But if we had that additional intelligence and we had the ability to look for it, but we don't. And then finally, the last piece of this is kind of like the integrated enterprise detection plan. So this is actually a screenshot of my Excel spreadsheet that has, again, all the data types of all the indicators sorted by pyramid effectiveness, and then the phases of the kill chain. And it says basically, if you have, what's a good one? If you have a file name and you need to find it in the installation phase, come all the way over, and here's your two options, hits and mirror. Mine, because I work for Mandy. Oh, glad again. David Bianco, biggest liar at BSidesAugusta.
There's your trivia question.
Yeah. So these are your options. These are the places that you would consider deploying your indicators. So you can notice that I've got it marked for deploying in two places. I don't like to only deploy it in one place. So you'll see that if I have no place to deploy my indicator, I'm red. This tells me where, as a detection program planner, I need to develop a new log source or deploy a new system or something to be able to detect those things. And I care about red up high more than I care about red down low. So they're ranked, but I still care about all the red. And if I only have one place I can put it, it's kind of yellow. It's like, warning, if this one snort sensor is down for maintenance, I'm blind for URLs in the action zone intent. Does that sound like a good idea? No. But I only have one place I can look for it. So there's no overlapping coverage. If they obfuscated it such that snort was fooled, maybe Bro wouldn't have been fooled. If I had Bro deployed, I could have both of them looking for the same thing, and the odds are increased that I would find it. And so this is your program plan. It tells you, just kind of at a glance, a whole lot of these other things that we talked about in the previous slides, and gives you an idea of where you're doing well. You know, all these greens at the top and at the right, right? Where you're not doing so well, all these reds at the top, some of these reds down here, and where you have some room for improvement. It also tells you where you actually have intel. So all these blank places I don't have intel about. I have no idea about what they do for reconnaissance, except for a few things. I have no, for some reason I have no email headers at all for spearfish. I don't know anything about their spearfishing, apparently. So you can derive most of the previous graphs from just this spreadsheet, but those are a little easier way of digesting it. So just to summarize, so the same thing, when we went from IDS to NSM, we're now talking about going from NSM to the next level, enterprise security monitoring, by collecting and aggregating data from all the systems across the enterprise and taking an intelligent look at the intel that we have, the intel that we need, and how we can most effectively use that to cover our own bases and inflict harm on the adversary's processes. We can get big improvements in detection and response capabilities, again, similar to the way we got big improvements when we added additional data to IDSs and came with NSMs. But the best thing is, I don't like these guys. If I can take them off, I would like to do so. I want to make it as hard as possible for them. And this is the way that we came up with. And I think this is the model going forward that a lot of the rest of the industry is. Large companies, small companies, mid-sized companies, they can all do this. A smaller or mid-sized company may find security onion, turn it on, do exactly this stuff. A larger company may need to have their own dedicated ELSA or a Splunk environment or something like that. But the architecture, the diagram I showed earlier, it should be the same at pretty much all the levels. So I'll take questions. Oh, by the way, my blog down here in case anybody's interested in reading. And I will, before I take questions, if there are any, I just want to mention I tweeted earlier about a contest to win Richard's book. I didn't do a trivia question, So I wanted everybody to tweet with the BSidesAugusta hashtag why you want a signed copy of Richard's book. And I did say that by the end of this talk, but by the time I started the talk, I didn't have a single entry. So if anybody wants one, get one in pretty quick. And I'll pick the one I like the best. I'll actually give you until the end of the next talk, and then give you some time to think about why you really need this book. And with that, I will open it up for questions.
You can take your presentation.